In this example, we're going to use substitution to solve a system of equations algebraically. And we're going to think about the first step in the terms of y equals mx plus b. So you can take both of those lines and solve them for y, and that'll give you two equations in the format y equals mx plus b. So let's do that. Take the first line and solve for y by dividing by 2. That gives you y equals 2x minus 4. Take the second line, you'll need to move the 2x first by subtracting it. And then you can divide by 2. And that's going to give you y equals negative x plus 14. So we have solved both lines for y. Now we're going to substitute the equations, which is the heart of this method. And then that's going to give us an opportunity to solve for the x coordinate. So take those two y equals mx plus b equations that you just wrote, and you're going to substitute the 2x minus 4 in the first equation for the y in the second equation. That blends the equations together, and now you can solve for x. So typically your variable ends up on the left-hand side, so we're going to go ahead and start by moving the negative x. Combine your like terms, that gives you 3x minus 4 equals 14. And in the second step, let's move the negative 4. Combine your like terms, and that gives you 3x equals 18. Last step is divide by 3. Divide the 18 by 3, and that gives you x equals 6. That's your x coordinate. So we have substituted the equations, we found our x. Now we're going to go back and plug the x coordinate into any equation and find the y coordinate. I'm going to plug it into one of my y equals mx plus b's. I'm going to take that to the y equals 2x minus 4 and just plug my x in there. So the 6, I'm just going to put it in for where the x is. That gives me 2 times 6 minus 4, which is 12 minus 4. And subtracting is y equals 8. So 12 minus 4 is 8. So now I can write my final solution because I have an x coordinate and a y coordinate that I can put into my solution. My final solution is the coordinate pair 6, 8, and that represents the point where these two lines intersect.